Hi, Assalamualaikum warahmatullahi wabarakatuh. How are you today? Hopefully you are happy because you can see this video horizontally now. Alright, by the way, thanks to Khalida, Izzati, Alisha and Azia for helping me out to set up the video horizontal. Alright, so today we will talk about the Friedel-Crafts alkylation, the third reaction in benzene. Basically, these two chemists, has proposed for this Friedel-Crafts alkylation. So we can say that alkylation, is the substitution of an alkyl group to hydrogen atom of benzene. Alright. So if we can see this example, I'm sorry for the keep moving video. Okay, so basically we have benzene. It will react with haloalkane. Haloalkane, or we call also alkyl halide, in the presence of Lewis acid to form the alkyl benzene. Okay, you can see one of the hydrogen from this benzene ring will be substituted with the alkyl group here, the R group from the haloalkane, to form the final product of alkyl benzene. And this reaction, and in this reaction we will also produce the side product, which is HCl. Okay, let's see a few more examples before we continue for the mechanism. Alright, you can see the example here. Alright, so basically here we have benzene. It react with 2-chloropropane. Okay, 2-chloropropane. This is an haloalkane. Okay, halogen and alkane. That is haloalkane basically. In the presence of Lewis acid, so we have AlCl3 as the Lewis acid here, and the product will be the isopropyl benzene and HCl. So what happened here is basically, remember in each of the carbon at the benzene ring we have hydrogen. Okay, each of this carbon has hydrogen. I just draw this hydrogen. Okay, what happened here is, because we have in benzene, the type of reaction that we have is electrophilic aromatic substitution reaction. We will undergo substitution reaction, right? So what happened is, this hydrogen will be taken out and substituted with the alkyl part here in the haloalkane. Okay, it will be substituted, this hydrogen. Okay, so basically this is the isopropyl. This is the isopropyl. Normally we can see the isopropyl in the skeletal form like this, right? So basically this is the carbon. We have one hydrogen here, and this CH3, this CH3 is basically this CH3 and this CH3, that branch. Can you see that? Okay, so it will be substituted here. Okay, substituted with the hydrogen from the benzene ring. And we have also the side product of HCl. Where this HCl come from? Basically, this hydrogen taken out, this part will be separated from this chlorine, right? So H and Cl, they will combine to form the side product of HCl. Okay, same thing with the second example. We can see here, benzene, it react with 2-chloro-2-methyl propane, and we form this kind of alkyl benzene and also the side product. So basically what happened, same thing, this hydrogen, now will be taken out and substituted with the alkyl group that comes from the haloalkane here. So we can see this carbon that has been break from the haloalkane. This carbon will be substituted to this hydrogen. You can see this carbon. Okay, and continue with the rest of the substituent. And as I said earlier, where this HCl coming from, this hydrogen that taken out, it will combine with this chlorine from the haloalkane to form the side product of HCl. Okay, so now let's see the mechanism. Right. For Friedel-Crafts alkylation, right? So I'll show you this first. Hope you can see that. Okay. For Friedel-Crafts alkylation, same for the mechanism. Okay, we still have 3 steps. It just same with the previous mechanism in halogenation of benzene and nitration of benzene. Remember, we have 3 steps. Step 1 is the formation of electrophile. Step 2, formation of uranium ion. And step 3, loss of the proton or loss of the H+. Okay. For step 1, okay, I want to emphasize for the step 1 first. Do you remember? For halogenation, okay, what kind of electrophile that we form? In halogenation, okay, for step 1, okay, for step 1, okay, this is for step 1, I just want to highlight step 1 first. For step 1, remember, in halogenation, what kind of electrophile we form? It is a complex. You can refer back to your notes. Okay, we form electrophile for halogenation in the form of complex. However, for the nitration of benzene, the type of electrophile that we were forming, okay, the cation. Okay, it is a cation. The cation that we form in the nitration is NO2 plus. Remember, we call it as nitronium ion. Okay, we call it as nitronium ion. So basically, for step 1, you have to aware that for the formation of electrophile, we have 2 types of electrophile. We have the cation and also the complex. Okay, therefore, for Friedel-Crafts alkylation, okay, this reaction is quite special because in step 1, we have both type of the electrophile that can be formed. Okay, where we can form both the carbocation and the complex. Okay, here in Friedel-Crafts alkylation, the cation is in the form of carbocation because we have carbon that has the positive charge. For the nitration, the NO2 has the positive charge. The nitrogen has the positive charge. So we call it as cation. For the Friedel-Crafts alkylation, we call it as carbocation. But still, the species has positive charge there. Okay, in the form of carbocation. Okay, and also we can have the electrophile in the form of complex. Right, in the form of complex, we have both. So, when we will produce carbocation, and when we will form the complex. Okay, so the answer is here. We will form carbocation in the first step, okay, which is the formation of electrophile in the form of carbocation if we have secondary and tertiary haloalkene. Okay, if we have secondary and tertiary haloalkene. And then when we will form the complex. Okay, the complex, here is the story. I'll let you know. Okay, we already talked about the secondary and tertiary haloalkene, right? Both of them will form carbocation. Okay, in step 1. However, what about the primary haloalkene? Primary haloalkene is a little bit different, right? Where in primary haloalkene, we can form both carbocation and complex. Where if we have a primary haloalkene that can undergo rearrangement. Remember the word rearrangement? if the primary haloalkane can undergo rearrangement to form a more stable carbocation, then it will form carbocation. Okay, in step 1. However, if the primary haloalkane cannot undergo rearrangement, okay, to form the primary to form a more stable carbocation, okay, it will not undergo rearrangement lah. Okay, if the primary haloalkane does not undergo rearrangement, therefore it will form the complex. Alright? Okay, so as a conclusion, we can say that for step 1, okay, formation of electrophile, we will form carbocation when we have secondary and tertiary haloalkane. Okay, and also we will form carbocation if we have primary haloalkane that can undergo rearrangement. Can rearrange. Okay, I just write like that. Primary haloalkane that can rearrange also form carbocation. What about complex? Complex, we will form complex when we have primary haloalkane, okay, that cannot rearrange. X here is cannot, right? Cannot rearrange. Alright, okay. So in the next video, we will see the mechanism for the formation of alkyl benzene with the first step, formation of electrophile, where we form the carbocation. Okay, see you in the next video.